Hi everyone, today we'll discuss integration as the limit of the sum. So this problem is given for us. Let's go. Summation n into n square plus r square. Limit n tends to infinity, r is 0 to n. This what we are doing is the given problem r equal to 0 to n by n square plus r square. So I am taking n square common. 1 plus r by n square. Okay. And this n, the power getting cancelled, this is equal to limits n tends to infinity summation r equal to 0 to n 1 by n 1 plus r by n square. So let here some adjustment. Let here r by n equal to x, 1 by n equal to 0. The limit, this all part, this one, this sum, let me put the color. This all part as 0 to 1. Integration 0 to 1. So therefore this will reduce to integration 0 to 1. 1 by n is, what is 1 by n? Dx by 1 plus r by n is x square. So 1 by 1 plus x square is tan inverse x limits. So this is upper limit tan inverse 1 minus tan inverse 0. Tan inverse 1 is 45, pi by 4. Tan inverse 0 is 0. So answer is pi by 4. Okay, next. Suppose limit n tends to infinity 1 by n, n plus 1, 1 by n plus 2, so on 1 by 2n minus 1. It is given. See here, this can be written as summation r equal to 0 to n minus 1 by n plus r. Limit n tends to infinity. This is same as limit n tends to infinity summation r equal to 0 to n minus 1 or n 1 by, if you take n common, 1 plus r by n. 1 plus r by n. Now what are our adjustment? 1 by n equal to dx, r by n equal to x, and the limit is 0 to 1, limit of integration. So this will reduce to 0 to 1 dx by 1 plus s. Integration of 1 plus x is 1 by dx by 1 plus x is 1 by log x, upper limit minus lower limit. Log of 1 plus 1 minus log of 1 plus 0. So this is log 2 minus log 1. Log 1 is 0. So value is just log 2. That's it. One more problem, same type. Limit n tends to infinity 1 by n square plus 1 square, 2 by n square plus 2 square, so on n by n square plus n square. So this limit n tends to infinity summation r equal to 0 to n 1 2 3 n. You see n square plus r square, and this should be r. Okay, because 1 2 3 numerator is also changing. This is limit n tends to infinity summation r equal to 0 to n r n square, if you take common, 1 plus r by n whole square. Okay. Now limit n tends to infinity summation r equal to 0 to n. What I am doing is here r by n and 1 by n. 1 plus r by n whole square. Now what are our adjustment? R by n equal to x, 1 by n equal to dx, and limit of integration is 0 to 1. So this will be 0 to 1, 1 by 1 plus x square, r by n is x, 1 by n is dx. So what is this? Do you remember? F dash x by f of x dx, log of f of x. So 1 by 2 log of 1 plus x square 0 to 1. 1 plus x square 0 to 1. Log of 1 plus 1 square is 1 minus log of 1 plus 0 square is 0. Log 1 is 0. This is 1 by log 2 or log of root 2 is the answer. One more problem. So fourth, I think, fourth or third. Limit n tends to infinity. Summation 1 by n square minus 1 square 2 by 2 by n square minus 2 square so on 1 by 2n minus 1. N square minus n square, it becomes 0. So n by. So okay, limit n tends to infinity summation r equal to 1 to n minus 1 1 by n square minus r square. See here this one, limit n tends to infinity r equal to 1 to n minus 1 n square if you take common 1 minus r by n whole square. N square if you take outside, this is 1 by n, limit 1 minus r by n whole square. So similarly r by n equal to x, 1 by n equal to dx, and limit is 0 to 1. Dx by under root 1 minus x square. 1 minus x square is integration is sine inverse x, 0 to 1. So this is sine inverse 1 minus sine inverse 0. Sine inverse 1 is pi by 2 minus 0 is pi by 2. This is integration. Integration as the limit of the sum. If it is given, we have to go like this. It is a series form. You have to convert the series into, remember the things. Remember few things, please. 1 by n equal to dx you have to take, r by n equal to x. Most of the time limits are 0 to 1. Then it comes into the shape 1 by x plus 1, dx by 1 plus x, integral log x. Again it is in the same, simple f dash x by fx, log of f of x. And this is under root 1 minus x square, sine inverse x. Like that simple questions. Please do subscribe the channel, share with your friend. Already you have subscribed the channel. Thanks for that. And please let me know which topic you want me to discuss. Thanks once again.